Let's talk about polynomials. You've done polynomials really since maybe pre-algebra, at least algebra 1. So what you see just below the title, polynomials, is the general equation or the general form for polynomials. The A's, the A0, the A1, the A2, all the A's represent the coefficients. So the coefficients can be any real number. And they're going to be multiplying by x raised to a power, and that power does have to be a positive integer, or I should really actually say a non-negative integer, because it can be 0, because technically that very last term has an x to the 0. That's why there's not an x, because anything raised to the 0 power is 1. So that's why we don't even bother writing it. But the point is, the exponents you see on x have to be numbers like 1, 2, 3, 4, 5, 6, 7. It can skip some, but we're not going to have any negative exponents or any exponents with fractions or decimals in them. So that's the general equation for a polynomial. So this can be things like 2x plus 5, a straight line, x squared, a polynomial, or more complicated ones like 8x to the 5th minus 4x cubed plus 7x. All those would be examples of polynomials. There's 3 things about polynomials we're going to talk about in this lesson. Should be pretty short and to the point. First is the degree. The degree of a polynomial is the value of its largest exponent. So let me go ahead and give you a warning. What we tend to do is just look at the very first term and assume that that's going to tell us the degree. Now that is often true, but there are times they'll write things in the reverse order where the biggest exponent is actually all the way at the end. So you need to look for whatever the biggest exponent on the x is, and that tells you the degree. Next is the leading coefficient. It's closely related to the degree because it's the number or the coefficient in front of the x with the largest exponent. So both of these numbers are going to come from the same term. The degree is the exponent that is the biggest, and the leading coefficient is the coefficient on the x that has the biggest exponent. So let's look at an example of that. It says find the degree and the leading coefficient for y equals 7x to the 4th plus 11x squared minus 9. So my job is to look for the biggest exponent that x has, and we see that is the 4. So I know right away my degree is 4. And the leading coefficient is always the coefficient on that same term. So I'm focusing just in here. That's all I care about for these two terms, the degree and the leading coefficient. The degree is the biggest exponent, that's the 4, and the leading coefficient is the coefficient that goes with that exponent. So the leading coefficient on this one is 7. I hope that seems simple. Let's do another one or two of these just to make sure it's clear. Let's say our equation was 4x minus 3x squared minus 6x to the 5th. So here's where you see what I tried to warn you about in that first slide. It's tempting for us to look for the degree, or especially the leading coefficient, and just focus on this first term, especially when we see the word leading. But that's not it. That doesn't give us either one. Our job is to look for the biggest exponent. So the biggest exponent is right here. It's x raised to the 5th power. So the degree is 5 for this polynomial. And the leading coefficient comes from that exact same term, so I'm just looking at this term. My leading coefficient is negative 6. So notice I do keep the negative with it. But that's all you got to do to find the degree and the leading coefficient. Next and last thing for this particular video is talking about the roots, or these can also be called the zeros or the x-intercepts of a function. And a root is a root of a function is a value that makes f of x equal 0. So it's going to be usually x values It could be a t if they're using a different variable. It's not wise, but it could be x or t, whichever one they're using for the equation. Values of x that when you plug them in, they make f of x equals 0. Those are roots of a function. Now, if you have seen other textbooks or hear other places, find the zeros of the function, that's the same thing. Or if they say find the x-intercept of that function, it's the same thing. So all three of these words are exactly the same thing. Finding them is all done the exact same way because they are the same thing. So we're going to plug the number 3 into these two equations. If our result is 0, then yes, it is a root of that function. So I'm going to choose to use my calculator here. I'm going to go to y equals and type in just the first function. Y equals x squared plus 4x minus 21. I go to the table. Okay, now I can see this one here, but just so I can change to where I can plug in whatever I want, remember you go to second window, that's the table setup, and change the first one, the independent variable, to ask. So that's saying they will ask you what x value you want to plug in. We want to plug in 3. This is especially helpful if you have to plug in decimals or fractions or really large numbers, things like that. So for this first equation, x squared plus 4x minus 21, when I plug in 3, I do get 0. So the answer is yes. X equals 3 is a root for the first equation. But now we need to test it for the second equation. So let's go back to our calculator, go back to y equals, and this time I'll plug in x cubed plus 3x. Okay, I go back to the table. It already has 3 plugged in. You can see the result here is 41. So since f of 3, because that's what I found, I plugged 3 into the function, is 41, that's not 0. So x equals 3 is not a root for that function. So those are the 3 things for today: the degree, the leading coefficient, and the roots.